basically, I'm going to walk you through how that activity should have gone mathematically and why it shows us why cells are so dang small. With our cubes, with our paper cubes, 2 by 2 by 2 centimeters was our first one. 6s squared is the formula for surface area. What was the surface area of that 2 by 2 by 2 cube? What's 6s squared for that? The middle cube is 4 centimeters. 24, yeah, because, hang on. 2 squared is 4, right? Because you do the squaring first. So 2 squared is 4, times 6 is 24. The volume is just s cubed. 2 times 2 times 2 is what? 8. Yeah, 8. 8 centimeters cubed. Good, that's volume. And surface area to volume ratio is 3 to 1, because 8 goes into 24 3 times. 3 to 1 is our surface area to volume ratio. You can think of that as basically the number 3, right? 3 over 1. Good. Second one, 4 squared is what? 4 squared is what? 16 times 6, Caleb?
94, 96.
96 centimeters squared. 4 cubed. Well, 4 times 4 is 16 times 4 is 64. Okay, and when we divide that out, what do we get? Yeah, it's 3 to 2, but I asked you to do it to something to 1. It would be 1.5 to 1. You can see that that is a smaller number than 3 to 1, right? Awesome. Then, if you did the math right on the last one, the ratio was the easiest because 6s squared, plugging 6 in as s, 6 times 6 is 36 times 6 is, nice, 216. And that's also what s cubed is, right? 6 times 6 times 6, 216 centimeters cubed. That ratio is, of course, 1 to 1. So somehow, as the cube is getting bigger, yes, surface area is getting bigger, yes, volume is getting bigger, but what's happening to the ratio of surface area to volume? It's getting smaller. That is key. That's what you should have seen doing this activity. Then the questions sort of tried to lead you to where we're going, but let's kind of write it all down here. This is where we left off in the notes, right? So here's the deal. To stay alive, cells have to get stuff in and out. And it can't all be by active transport. Right? The cell can't just spend energy and force things in and out of it. A lot of it has to happen from straight diffusion. Oxygen, water, carbon dioxide, all those things have to diffuse into and out of the cell for that cell to stay alive. And it turns out that the cell membrane is key to letting that happen, right? Because the cell membrane is permeable. Stuff can diffuse across it. So ideally what we want is as much surface area, as much cell membrane in relation to how much cytoplasm there is as possible to get enough stuff diffusing in and out to keep the cell alive. Well, as a cell gets bigger, we just proved mathematically that its surface area to volume ratio gets smaller. That's what you just proved. Well, you can think of surface area to volume ratio as cell membrane to cytoplasm ratio. It's the same. If we're thinking in terms of the cubes, it's paper to air, right? The paper is the surface area and the air inside is the volume. In a cell, it's not paper to air, it's cell membrane to cytoplasm. In a very real sense, the cell membrane keeps the cytoplasm alive by letting enough stuff in and out. And if the ratio goes down, the cell's going to die. So the simplest way to put this is big cells don't have enough cell membrane to let enough stuff in and out to keep their cytoplasm alive. That's the best I can phrase it. So again, it's math, I know, but the math bears out what we just said, that as any three-dimensional thing, it doesn't have to be a cube, it's just cubes make the math easy. As any three-dimensional thing gets bigger, its surface area to volume ratio gets smaller. That can be a good thing for something like, say, a warm-blooded mammal. But it's a bad thing for a cell that needs to get oxygen and water and carbon dioxide diffused in and out of it at a pretty high rate to keep itself alive. It's bad for a cell to be big. It's why living things have never evolved cells larger than about 1 millimeter, because they wouldn't have enough surface area for diffusion to keep them alive. That's the main message for today. Everybody good? That'll be a question on the test. You'll need to be able to explain this with math. Okay. Couple of things. I checked, and I think most of you have forgotten about another thing that was due today, which was the mitosis scavenger hunt. Remember that from the day I was out? That Wednesday, yeah. Yeah, so you're going to want to finish that up and turn it in. And the snowman contest, I'm going to extend the deadline. I said those were due tomorrow. Let's make it Wednesday, so you can have some time to pretty them up. Feel free to leave snowman parts in that corner of the room with your name on them as these sort of start to come together. But yeah, you need to make sure that that mitosis scavenger hunt is turned in. I'll give you till the end of today to get those done and turned in. Riley.